Hello students, now let us take the first type of function and that is called onto function or surjective function. So these are two different names of one type of function. So to understand this function, let us take two sets, set A and set B, and under F, let's say the mapping is like this. Okay, so to say or to decide if this function is onto function or not, we have to first write what is the codomain of the function. Codomain of the function is the second set, that is 1, 2, 3 or set B. Next, we have to decide on what is the range of the function. The range of the function is set of all output values. Okay, so here range will be output values means what? Output values means those values of the codomain onto which arrows are there, right? They are outputs of some x values. So therefore, here the output values are 1, 2 and 3 because on all of these elements, arrows are landing. If codomain is equal to range in that function, if these two are same sets, then F is called onto function. And if codomain set is not same as range set, then the function is called, there is a specific name to it, into function. Fn means function. Okay, very simple. Whenever you have to decide if a function is onto or into, just find the codomain, find the range. If these two are same, then it is onto function. If these two are not same, then it is into function. That's all. Now, the definition will be something like this. Every element of codomain should be the image of some element in the domain. If this is happening, then F is onto function. So let us see the definition as well. A function f maps from A to B is said to be onto if every element of B, which is codomain, if every element of codomain is image of some element of A, which is domain under F. That is, for every element of the codomain, there exists an element in the domain such that f of the element in the domain should be equal to the codomain. Okay, fine. So ultimately, what are we doing here? We are finding the codomain, we are finding the range, and codomain, if it is equal to range, then that is a onto function. Simple. Let us take some examples so that a function which is not onto is called into function. Okay, this also we have studied. Let us take some examples. Let us say there is a function f which is mapping, there is a function f1 which is mapping from set x1 to set x2, and the mapping is like this. Fine. So here clearly I can see range is not equal to codomain. Why? Because there are some elements left over. So therefore f1 is into function. F1 is into function. Next, let us take another function and say the mapping is like this. Again, we can see some elements of the codomain are not mapped to any elements in the domain. So therefore, this is again a into function. Okay. Next is, we have two sets here, and under the function, the mapping is like this. So clearly we can see codomain set is ABC, and that is same as range set. Isn't it? Right? So no elements are left over here. So therefore, this function is onto function. So simple. So here again, this will be a onto function. Onto function. Why? Because codomain is same as range. Okay, fine. So now let us take some more examples. Check if the following functions are onto or into. The first function is having its domain as r plus. What is the meaning of r plus? Or you can write r plus as 0 to infinity. All positive real numbers. 0 is neither positive nor negative. So therefore 0 is not included here. All positive real numbers. That is written as r plus. And what is our codomain? That is all real numbers. Okay. So we have the function as log x. Let us take the graph of log x. Okay, so let me erase this for a moment. So this is the graph of log x. For the domain R plus means our input values are from 0 to infinity, right? Okay, so let me write it. This is domain of the function 0 to infinity. So my input values are from 0 to infinity. Okay, so therefore for 0 to infinity, this is the shaded part of the graph. Okay, so for the shaded part of the graph, what is the output values? So the output values are starting from minus infinity to infinity. There is no y value which is missing. So therefore, range of the function is all real numbers. What was codomain? All real numbers. So range is equal to codomain set implies function is on 2. Got it? Right? So how did we decide here? We have taken the help of the graph of the function. Why? Because graph tells you for input values, what is the output values. That is what is graph. Okay. This graph is saying that for all values going from 0 to infinity as input, the output values are like this. Okay. So that means you have the most negative value also, that is minus infinity, because this graph keeps on going like this and this graph keeps on going like this. So therefore, the y value starts from minus infinity and no y value is missed, and as you go above and above, all the y values are taken. So therefore, range has become all real numbers. Here clearly it is given codomain is real numbers. So therefore, it is a onto function. Let us come to this one. Y is equal to e power x. Okay, so the domain is all real numbers. So if all real numbers are my input, then this is the part of the graph which I am considering, means the whole graph, right? So for this, the codomain set is all real numbers. What is my range? Range is nothing but set of all output values or set of all y values. So here y values, of course these negative values are not being taken. Why? Because this line is never cutting the graph. If this line is never cutting the graph, that means this y value is never taken by the graph, right? Okay. So is y is equal to taken by the graph? Is y is equal to 0 taken by the graph? No, because y is equal to 0 line is never touching the graph or cutting the graph, isn't it? When you leave the graph like this, that means this graph is approaching this line indefinitely. Indefinitely means as you go on and on, this graph keeps coming nearer and nearer to this line, but it never touches or cuts this line. Okay. So therefore, this y value is also not taken. And any value of y which is higher than this will be taken. And like this, as you go on and on, they will be taken. And it goes on till infinity, right? So therefore, any value more than 0, that y value is taken, and all the y values till infinity are taken from 0 open. So here range is 0 to infinity. What is codomain? Codomain is, here we have written, so these two are not equal. That means this is a into function. Into function. Okay, fine. So what are we doing here? In the domain of the function, find range of the function. In domain of the function, find range of the function. And this will be our step 1. Step 2 is compare range and domain. Compare range of the function and codomain of the function. Okay, so that's all. If you do this, then you will get the answer. Very simple. Now, let us take some CET questions. Okay. F maps from R to R, f of x is equal to x square plus 1. Is it onto or into function? Okay, so let us do it using graphs. Okay, so we know the graph of y is equal to x square. How is the graph of y is equal to x square? It's a parabola. This we have learned in parabola chapter, in functions chapter of class 11, right? So now we should know what is y is equal to x square graph. Y is equal to x square graph is a parabola which is upward and it is passing through origin. Okay. So if we want y is equal to x square plus 1 graph, then how will the graph be? Okay. So to draw this graph, we can understand like this. Now, whatever is the output value here, that is increased by 1 unit. So therefore, this point will be shifted up by 1 unit. This point will be shifted up by 1 unit. Okay, this will be 1 unit. This point will be shifted up by 1 unit. In the same way, the whole graph. So therefore, the new graph will also be a parabola, just it is shifted up by 1 unit. Okay. So this is a general shift, means you should have, you can learn it now. If y is becoming y plus 1, means the output values are increased by some constant. So let us say k, then shift the graph upwards or downwards by, you can write mod k units. Okay, mod k units. Upwards if k is positive. And downwards if k is negative. So if you are drawing y is equal to x square minus 2, then how will the graph be? Because k is negative, you have to shift downwards. How many units? Mod k units. What is k? Minus 2, right? Isn't it? So k is minus 2. So therefore, mod k is 2. So shift the whole graph by 2 units downwards. So that's it. This is minus 2. The same graph has become like this. So here it is like this. Now, whenever we are deciding if it is onto or into function, we are interested only in comparing range of the function and codomain of the function. So what is the codomain of the function? That we already know. That is all real numbers. And what is the range of the function? The input values are all real numbers. So the input are all real numbers. For these input values, what is the set of output values? Okay, so the set of y values, just take the horizontal line here. This y value is never taken, this y value is never taken, this y value is never taken, this y value is never taken. The first y value will be taken and that will be 1. And after that, so on till infinity. So the range of the function will be from 1 to infinity. What is our codomain? All real numbers. Implies this is a into function. As codomain is not equal to range. Okay. So always whenever you are doing this onto or into function or one or many one, that will be the next type of function. So whenever you are doing questions of this in competitive exams, always do it using graphs, and you will be able to do the you will be able to solve the question much faster. Okay. So let us take the next question, and the next question is f maps from R to R. So domain is R, codomain is R. F of x is equal to mod x is onto or into function. Okay, as I told you, do it using graphs. We know very well how the mod x graph is. Okay, this is y is equal to mod x. Okay, so to decide if it is onto or into function, we should compare codomain and range. What is codomain? R. What is range? For these input values, means for all real numbers as input values, what are the y values? Okay, let us start. So this y value is never taken, this y value is never taken. The first y value that will be taken is 0, and all the other y values will be taken, right? So therefore, the range of the function is from 0 to infinity, which is certainly not equal to codomain. So therefore, this is into function, as range of the function is not equal to codomain. Okay, let us take the next question. F maps from R to R, f of x is equal to greatest integer function of x. Is it onto or into function? Again, this is a graph which is well known, which has been studied in class 11. This is also called step function because the graph looks like steps. Okay, so this is one, and okay, so first let me draw it. Okay, and so on like this, just goes on and on. This is the graph of greatest integer function. Okay, so these dotted lines are not the part of the graph, they are just for reference. Okay, and like this. So the graph will jump at integers. So this is 1, this is 2, this is 3, this is -1, this is -2. And here means this is also red line only. Okay, so 1 and 2, and this is -1, this is -2. This is the graph of greatest integer function, and it goes on like this in the leftward also and towards the right as well. Okay, so now let us come to the function. The domain is all real numbers. The codomain is all real numbers. Okay, so we want to find the range of the function. The input values are all real numbers. Means you are giving all values that are there on x-axis. Okay, so for all of the input values, this is the graph of the function. Now let us see what are the output values. Okay, so let me show you from here itself. So -2 is a y value which is taken and it is there on the graph. But for anything other than, means more than -2, like this, -1.5, -1.3, -1.2, these corresponding to these y values, there is no point on the graph, right? And again, it is there at -1 only. For y is equal to -1, there are points on the graph. And let us say if you take -0.5, -0.3, -0.1, again, there are no points on the graph. So if you observe, the output values are only integers. So therefore, the range will be set of integers. So clearly we can see range of the function is not equal to codomain. So therefore, this is a into function. Therefore, this is a into function. But if you have this graph in your mind, then you need not even draw it. Right away, you can give the answer. The range is set of integers. So therefore, it is a into function. Okay, so let us take one more question. F maps from R to R. The domain is R. Codomain is also R. Okay, this is codomain. And f of x is signum of x. Okay, we know very well how the graph of signum function is. At 0, y value is 0. At any positive input, the y value is 1. At any negative input, the y value is -1. How do you write it? F of x is equal to -1 for x less than 0, is equal to 0 for x is equal to 0, and is equal to 1 for x greater than 0. This is a graph again we have studied in the chapter of functions of class 11. Okay, so the input values are all real numbers. So for all real numbers as input, so this is the graph. Okay, now study the y values. So the y values, they start only from -1. Okay, they start only from -1. So see, this ball does not mean that -1 is not taken. For all of these x values, the corresponding point on the graph is here. Okay, let me draw it in red. Okay, for these input values, the corresponding point is here. And the y value is -1 itself. This ball is saying that at x is equal to 0, y value is not here, it is here. So at x is equal to 0, the point is here. That is why a hollow ball is put here, so that you understand that at x is equal to 0, the y coordinate is not here, it is here. That's all. Okay. So therefore, from here, we have understood that the first y value is -1, and the next y value is 0, and the next y value is 1, and these are the only y values. So what are the y values? -1, 0, 1. So how do you write a discrete set? Like this. What do you mean discrete? Means only these values are there in our range. If you write a continuous set, something like this. This means every real number between -1 and 0, -1 is included, 0 is not included, right? And so this is a continuous set. But if you need to write discrete set, means only some values, then you write it like this, flower brackets, -1, 0 and 1. So clearly range of the function is not equal to codomain of the function, implies into function, okay? So very simple. As I told you, do it through graphs and the answer will be very quick, okay? And of course, when you are doing it in competitive exams. Okay, so this is how we have taken some CET questions on two functions.